Quadratic equations are used for several types of situations like projectile motion or optimization problems. So the first two we'll do are projectile motion, which just means that you throw something, makes a parabola. Optimization is like the last one we'll do with finding the widths of a rectangle. When you see a word problem with a quadratic equation, you'll be looking for one of two things, or maybe even both. You'll be looking for the maximum or the minimum, which, as you know, is the vertex. You'll also be looking for the solutions, which are also known as the x-intercepts. We have found these things before. Okay, we're going on the first one. Ball is thrown straight up with an initial velocity of 56 feet per second. The height of the ball after t seconds after it is thrown is given by this formula here. So usually you'll be given the equation. I don't expect you to know how to come up with one. Let's draw a picture. You have someone who is throwing this ball up. Draw yourself a little picture, okay? We throw it, and it goes like this, and then it hits the ground. Isn't that usually how a ball is thrown? Yeah, usually that's how it works. So this is my ground. At some point, it's going to hit a maximum height. And at some point, where's it going to hit? The ground. Because that's how the earth works. Okay. My first question for you is, what is the maximum height? So you have yourself a little picture. The maximum height, what is that point called? It is called the vertex, and it is a maximum. So you need to figure out what this point is. So we're going to figure out what that point is, and then we'll label it in a little bit. We are using that equation that you see at the top, and we're finding the vertex. So let's just start by saying, if we have this equation, smart idea to write down what's A, what's B, what's C. Okay, so look at that equation and think about, remember you got ax squared plus bx plus c. I know you have t in this problem, but same type of thing. What is A? Is A 56? No, A is negative 16. A is negative 16 because it's a number in front of the squared term. Okay, now what is B? B is 56, the one that has one variable and no exponent. What is C? C is 0. So if you remember when we're talking about standard form, C, this is called the y-intercept. So apparently this person was sitting on the ground actually when they threw it. So this is the start height. This person threw it from the ground somehow. Maybe that's not a super accurate equation to describe it. We're going to go with it. We're going to assume that they threw it from the ground. So your y-intercept, your c value is your start height. Okay, to find the maximum height, you've got to find the vertex. Same way we found the vertex before. That should say 56, by the way. How do I find the axis of symmetry? X equals negative b over 2a, which is part of quadratic formula. So you take your negative b, so that would be negative 56, over 2 times negative 16. What is 2 times negative 16? It is negative 32. Lucas, you got a pencil? And go ahead and divide that. There's a reason why I've been making you show your work for weeks now. It's because I've been telling you, hey, remember, sometimes you're going to get decimals. Sometimes you're going to get decimals. Today is the day that you get a decimal. You can't just go to your table on your graphing calculator and get your answer. What do we get, Carson Sullivan?
1.75.
Okay. So that would be the x value for the vertex. That's pretty important. To figure out your y value, you take your x value, you plug it in. So the height, I'm going to write it like this just because that's what my equation says. It says h of t. We're just finding the y value. If I plug in 1.75, into this equation that I'm going to put everywhere I see a t, because this was t. Everywhere I see a t, I put 1.75 in parentheses, please. Now, you could do this in pieces, or, as we've talked about, you can type this all in your calculator at once. Please make sure you use parentheses and type it in exactly as you see it. I need you to have a calculator right now. If you don't have one out on your desk, I need you to get one. I need you to do this yourself. So take what you see typed here. I'm going to highlight it. It'll be this part. You need to type that in your calculator exactly as you see it. You have replaced t with 1.75. You got to figure out what the y value is, your maximum. If you get a decimal, if you get a negative, something is wrong. Try again. Type it in literally exactly as you see it. 56 in parentheses 1.75 minus 16 in parentheses 1.75 squared. You should get a whole number on this one. You should get 49. If you don't get 49, something is wrong. Try again. Okay, if you need help, ask for help. You get, so we have these two numbers now, 1.75 and 49. That's your vertex. Might as well label that. So go to your little picture. And at the top, we now know that this point is 1.75, 49. The question is, which of these numbers is the maximum height? What do you guys think?
49.
The 49, because h is the height. And so when you solve for the y value, you're solving for the height. The x value, or t, is time. So after 1.75 seconds, the height is 49 feet. So maximum height is 49 feet. Okay. We're going to do next problem all together. The last part here, you're going to kind of do on your own. What's the height of the ball after 1 second? So this one is not asking for the maximum min. It's not asking for the x-intercept. Where do I put that 1 second? T, for time. So we are going to take our equation, and we're going to plug in 1 for t. So after 1 second, you got to figure out where it's at. What's the height? Oops, I messed that up. This one you might be able to do in your head. If you want to type in your calculator, you can. But I know that 56 times 1 is 56. And then 1 squared times negative 16 is 16. What is the height after 1 second? 40 feet. Okay, and the last question, so we've done vertex, we've just plugged in a number, and then the last one, how many seconds will it take to return to the ground? What am I looking for if it's hitting the ground? Is that the vertex or the x-intercept?
When it hits the ground?
Yeah.
X.
That is your x-intercept, because it's when your height is 0. So like your y value. If my height is 0, then I take my equation and I replace the height part with 0. And you got to solve for the time. Okay, what I need you to do right now is you can use your flowchart or you can just think about it. I need you to think about what's the best way to solve that quadratic, please, and you can discuss with people around you. What will be the quickest way to solve it? Because quadratic formula works every time, but it's not usually the quickest. You start at the top right and you go through. Kayla, where do you end up? Factoring.
B equals 0.
It has an A term and a B term. You can factor with a GCF. It'll be beautiful. It'll be fast. It'll be the best. So look for a GCF, please. What can we need the highest number that 16 and 8 can both divide by? It is 8. And then you can also take out a T. So 8T, which would leave you with 7 minus 2T. You have two factors. Please remember that you take those two factors and you split them up. And you set them both equal to 0. 8T equals 0. And 7 minus 2T equals 0. And you need to solve both, please. We are doing a word problem, and so it's okay to go ahead and get decimals. In fact, that's preferred. So instead of leaving that one as a fraction, give me a decimal, because we're talking about seconds. We don't do seconds and fractions because that's weird. So you need to solve both of these equations. Solve both of those equations. Solve both of those equations. You get two options. You get the time, so when will it return to the ground? Will it return to the ground after 0 seconds or after 3.5? Which one actually makes sense to answer the question? 3.5, the other x-intercept is where it started. At 0 seconds, it was at the ground, because that's where we threw it from. And then it returns to the ground at 3.5. So your correct answer is this one. Because the other one doesn't make sense. I mean, it's correct. It was at the ground at that point, but we're talking about after it was thrown. Okay, I don't think we're going to do all of the next one, but we'll talk about it. So let's read it and talk about it, and then we'll talk about how we would solve it, and we're not actually going to do that because of time. I don't want to have notes forever. The Empire State Building is 1,250 feet tall. If an object is thrown upward from the top of the building at an initial velocity of 38 feet per second, its height t seconds after it's thrown is given by that function. How long will it take for the ball to hit the ground? Draw yourself a picture. You have the Empire State Building. It is really tall. Okay? And you got someone at the top who decides that they're going to throw an object. Let's hope that it is safe. Okay? They throw it off the building. And we're going to assume they got a pretty good throw because, there we go. They throw it off the building and makes a parabola type shape. And then it hits the ground. So you've got some important points here. You have the y-intercept. That'd be where it starts. You have the vertex and then where it hits the ground. Okay, we're just going to discuss how we would solve this. I'm going to start by looking at the equation and writing down A, B, and C. Guys, what's A? Negative 16. What's B? 38. What is C? 1250. Okay. I'm going to keep doing this because I know this is on your assignment today. C is the y-intercept. It is the start height. Okay. Now the question is, how long will it take for the ball to hit the ground? Can you please discuss with the person next to you, what are you looking for? Are you looking for the y-intercept? Are you looking for the vertex? Or are you looking for the x-intercept? What do we need when it hits the ground?
X-intercept.
Here, what do I want?
X-intercept.
Yes. Why?
Because it's like the part on the bottom, like that's how it where the ball touches the floor.
Part on the bottom is where y equals 0, and our y in this case is height. So when our height is 0, it hits the ground. So you were looking for the x-intercept. We're going to jot that down. So you would find the x-intercepts. Okay, let's talk about, look at this equation. Just think about it. Based on what you see here, what do you think the best option is? Going to be to solve for the x-intercept. Discuss. You can look through your little flow chart. What do you think is going to be your best option? Do you guys want to factor that? No. That would be, it'll not turn out great. You could try. You certainly could. You see really big numbers. What do you think is going to be your best option?
Quadratic.
Just use quadratic formula. Your numbers are that big, quadratic formula is going to be a good option. So we're not actually going to do it because time. But in order to solve for your x-intercepts, you would use quadratic formula because you like your life, and you can try factoring. By all means, you go ahead. But I would not. Okay, and then the last thing, you got a rectangle. The length of the rectangle is 6 more than its width. So draw a picture. The length is 6 more than the width. So here's my width. If the length is 6 more, what do I label the length? 6 plus the width. So W plus 6 would be the width or length. And it says that the area is 91 square inches. So here's my area. Find the dimensions of the rectangle. This is called optimization. You're finding like lengths and stuff. How do you find area of a rectangle? Length times width. Your length is W plus 6. Your width is W. We've done something like this before. So the area is 91. And then you multiply your two lengths together. Because one of these has 2 terms, it needs to go in parentheses. You're taking your 2 and multiplying them together. That's not really an equation that you can solve right now. So you need to distribute. And get 91 equals W squared plus 6W. If you're going to solve for W, what do you need to do first? Like we're solving for W to get the width so we can get the length. You can't solve it right now because what needs to happen? Think about what we talked about for the last week. What does it need to be equal to? 0. So you need to move that 91 over. So this is the equation that we have. W squared plus 6W minus 91 equals 0. Look at your chart, your flow chart, or think about it. If I want to solve for the width, or W, what's the best way to solve? Start at the top right of your chart. Go through. A is 1, B is 6, C is negative 91. Go through, talk about it, think about it. How should you solve? 0. A was 1. B, was B an even number? Yes. How should you solve this? Complete the square. Complete the square. It'll be a lot faster than quadratic formula. We're not actually going to do it because time. And I don't want to spend all day on this. I wrote quadratic formula. Can you ignore me? We're going to do completing the square. Okay, so to summarize what we talked about, here are some things that you're looking for. If you're solving for the vertex, it will ask for a maximum. So like the max height or the minimum height. If we're looking for the x-intercept, pretty much the only thing that you're going to hear is one of two things. When does it hit the ground? The other thing that you'll hear is if you have like an animal or something. How far did the blank, like the frog or the kangaroo, how far did it jump? All right. I know it's a lot. The good news is that your assignment is only 4 questions long. So